Hey there, everyone. So sometimes students get hung up on the conservation of momentum calculations, primarily using this formula right here, which tells us that when we have a collision of objects, the momentum before is going to be equal to the momentum after for the entire system. Now, the entire system in this case is going to include both objects before and both objects after the collision. So a couple of things to note. On the formula, I put a subscript of I and F for initials and final velocities, just to try to help distinguish between the two. Sometimes you won't see that in the formulas, sometimes you might see it written completely out, but the general idea is that we need to separate our initial values from our final values before we get started. So if you feel like you are possibly going to get these mixed around, one thing you can do is before you start doing any of the computations or plugging values into the formulas, make yourself a little list. So I do this as 2 columns, and then like in between the columns, I will put mass 1 and velocity 1, and then mass 2 and velocity 2. So I'm going to have object number 1 and object number 2. Then I come back to the readings, and I'm just going to put this first item here as object number 1. So my initial mass of the first object is 3.4 kilograms. That is also going to be my final mass, because the mass of my balls does not change once they have this collision. Okay, and now for the velocity, it tells me that this initial, or this first mass, oh my goodness, first mass is rolling to the right at 1.2 meters per second. So its initial velocity would be a positive 1.2. And now tells me here the second ball, so this is going to be my second object, the mass is 2.8. And again, my mass is not going to change from beginning to after. And it's rolling to the left at 1.9 meters per second. So because it is rolling to the left, its initial velocity is negative 1.9. Okay, then it transfers here and it tells us after the balls collide. So now we're going to go over here to this final column. The 2.8 kilogram ball is rolling to the right at 1.1. So my 2.8 kilogram ball, that is the one I had as mass 2. So my final velocity of object number 2 is to the right at 1.1. So that's going to be a positive value. And then the question asks us, what is the velocity of the other ball? So that is going to be our unknown. Once you have your information separated into initial and final, if you choose to do it this way, you need to recognize that all of your initial values will be on the left side of the equation, and then all of the final values will be on the right side of the equation. So I'm going to take my initial mass 1, which was 3.4 kilograms, times initial velocity 1, which is 1.2. Okay, add that to mass 2's initial, which is 2.8, times velocity 2's initial, negative 1.9. Okay, once I get that, then I can move on to the final side of my equation. So now I'm going to use all of the values in this column. So my 3.4 is going to be multiplied by x because I don't know what that final velocity of object number 1 is. Okay, plus, and then I'm going to have my 2.8 times 1.1. Then grab your calculator and start doing some computations here. So I'm first going to do 3.4 times 1.2 plus 2.8 times negative 1.9. And so my left side of my equation here turns out to be a negative 1.24. And on my right-hand side, I can't multiply that out yet, so I'm just going to leave that as 3.4x, but I can go ahead and do the 2.8 times 1.1, and that gives me 3.08. Now, in order to solve this for x, I need to do some algebra, so I'm going to subtract the 3.08 from both sides. And that gives me a negative 4.32 is equal to 3.4x. Then I'm going to divide by 3.4, and that gives me x equals negative 1.27059. And that would be meters per second, but now I need to go back and look at significant figures, which it looks like I have two significant figures across the board, so I am going to then round that to a negative 1.3 meters per second would have been the final velocity of that second ball.